Okay, so welcome back. Now today we're going to do some examples of how we determine whether an equation has a graph that is an even or odd equation, or an odd function versus an even function. And so in this example here, I have three that we're going to work through. And so how do I determine whether this is even or odd? Well, we're going to replace f of x with f of negative x and see what we get. Okay? So let's do that here. So f of negative x equals 8 times negative x to the fourth power, right? So again, be careful of the signs. Minus 3 times negative x quantity squared plus 1. And so now what I'm going to do is I'm going to simplify the inside here. And so what do I get here? Well, this is an even, right? So I'm going to get negative x 4 times. So that's going to give me a positive value because a negative times a negative times a negative times a negative is positive, right? An even number. So that means I'm going to get x, 8x to the fourth. Okay? And then here, I'm going to get negative x squared. That's also going to be positive. Negative times a negative. So that's going to give me positive. So this is going to be minus 3x squared. Okay? And then plus 1. Now, notice that I got the same thing. Right? So now, therefore, this is an even function. Okay. Now let's look at the next one. Let's see what we get here. Again, we're going to replace x with negative x. And then we're going to do the same thing here. So we get 6 times negative x quantity cubed minus 9 times negative x. Now let's see what we get. So now this is going to be, since this is odd, this is going to give me a negative x cubed. So this is going to end up giving me a negative 6. Right? So again, if you don't see that, just think. It's negative x times negative x times negative x. Okay? Or another way to think about it is you can think about this as negative 1 times x raised to the third power. And then you can use the distributive property or the power rule, right, and distribute the 3, and then you get negative 1 cubed, which is negative 1, and then you get x cubed. So you still end up with negative x cubed. Okay? So either way, you're going to get negative 6x cubed. And now you get, oh, here we go, negative x and a negative, so that makes this plus 9x. Okay, now, this is obviously not the same as this. Okay? So let's see if it's, no, so it's not even, right? So it's obviously not even. But let's see if it's odd. Okay, so let's see if I take out a negative, factor out a negative 1, I get 6x cubed minus 9x. Aha! So now, this is the same as that. So this turns out to be the opposite of f of x. So, because this ends up with the opposite of f of x, then it's an odd function. Okay? So now, so in other words, here we ended up with the opposite of f of negative x, and we ended up back to f of x, right? And so it's even. Here, we put in negative x, and we got f of negative x, and we end up with the opposite of f of x, so it's odd. Okay, so let's look at this one. Now let's do f of negative x, 3 times negative x quantity squared plus 5 times negative x. Okay, so now negative x squared is just going to give me a positive x squared, so that's going to be 3x squared. This is going to make this into a minus 5. Now, do I get back the same equation I started with? Do I get f of x out? No. No, I don't. I got a minus instead of a plus. Okay? So it's not even. Now, if I take out a negative, if I factor out a negative 1, I get negative 3x squared plus 5. Now, do I end up with the same thing in here? No, I don't. Okay? So it's not the opposite of f of x either. So it doesn't match even or odd. So this would be neither. Because I can't make it fit either one. Now, before I let you go on this one, there's also another way that you can see whether these are even, odd, or neither. Look at the exponents on the terms of the polynomial. So if you notice here, the exponents here, and by the way, we can look at this as x to the 0, right? X to the 0 is 1, right? So if you look at all of these exponents, what do you notice about the exponents? They're even. So if they're even exponents, then you'll always get positive values for x when you plug it in, when you plug in negative x. So if all of the exponents are even, then it's going to be an even function. And if you notice here, with this one here, notice the exponents on either all the variables here, the terms here, the x's, all the exponents are odd. And so we end up with an odd function. And then notice on the last one here, there's a mixture of even and odd exponents. Okay? So here's the takeaway. This is the way you do it algebraically. Make sure you know how to do it algebraically. But also, if you look at the exponents, if all of the exponents are even, then the function's even. If all the exponents are odd, then it's odd. If you have a mixture of even and odd exponents, it's neither. And that's it. Have a great day.